we've got another set of formulas that we're going to use, again on your formula sheet, the reduction formulas. Okay, so here they are, sine squared of theta, cosine squared of theta, and tangent squared of theta. Okay, and let's look at what we get on the other side. Here we have a cosine of 2 theta, a cosine of 2 theta, and a cosine of 2 theta. Oh, they're all in terms of cosine of 2 theta. Things, slightly different around them. So let's just look where they came from. So remember, from the ones we just looked about, from the double angle formula, one of the options for cosine of 2 theta is 1 minus 2 sine squared theta. Right? So if we just solve for sine squared of theta, bring this over, bring that over, we get 1 minus cosine of 2 theta, divide by 2, voila. There's our sine squared formula. Okay. We do something very similar. We have the other form for cosine of 2 theta for double angle formula of this, solve for cosine squared of theta. So add 1, divide by 2, cosine squared theta equals this. Ta-da. Tan squared of theta is just sine squared theta over cosine squared theta. And we just figured out these equations. So put those in a ratio, 2's cancel, and we get 1 minus cosine 2 theta over 1 plus cosine 2 theta. All right, so if we've got a trig function squared, we can reduce the power. That's why they're called reduction formulas. We kind of trade this power for a double angle. Okay, that's the trade-off that we make. So let's do some examples where we use this. Write an equivalent expression for cosine to the fourth of x that does not involve any powers of sine or cosine greater than 1. So we don't want any exponents. Okay. All right, so cosine to the fourth of x, I'm going to say is cosine squared of x times cosine squared of x, right? Or cosine squared of x squared. All right, well, I have this equation right here. That's a power reduction formula. So I'm going to say it's 1 plus cosine of 2x all over 2, and this whole thing squared. Okay, cool. However, I really want no powers of cosine greater than 2, so I'm not quite done, right? If I multiply this out, I'm going to get 1 plus 2 cosine of 2x plus cosine squared of 2x, all divided by 2. No, all divided by 4. Yeah? I just multiplied this numerator out. All right, so now I'm going to need to replace this again. And maybe to make this easier, I'm going to write this as a bunch of different terms. I'm going to divide this 4 into each of these terms. Right? Okay, so now I still have this problem where I've got this exponent here. So I need to do it again. I'm going to replace this, use this formula here, 1 plus cosine of 2 theta over 2. For this cosine squared, what is my theta in this case? Now my theta is 2x. So what am I going to get? I'm going to get 1 plus cosine of, this is the key moment. What do you think? 4x. Right? Because it's 2 times whatever my theta is 2x. This is the easy place to make a mistake. Okay, great. Then I can multiply this out. I could say 1/8 times 1 plus cosine of 4x. If I wanted to keep going and multiply that out, I'd have plus 1/8 cosine of 4x. Whoops, ran off the page. So I could add these together, right? The point is, I had to use this power reduction formula twice, and that's not uncommon. Okay, a lot of times on these questions, you do have to use it twice. And I ended up with a cosine of 2x and a cosine of 4x. Okay. Okay, let's look at another example. Use the power reducing formulas to prove this. They want us to prove that sine cubed of 2x equals 1/2 sine of 2x times 1 minus cosine of 4x. Okay. How can I do this? Well, they tell us to use the power reducing formula. So let's go back to that. The power reducing formula for sine, because here I've got a sine cubed. I don't have a sine squared, but I could write this as sine squared of 2x times sine of 2x, right? Yeah. All right, well, sine squared of 2x is going to be this thing here. So I'm going to replace this with 1 minus cosine of what? What's my theta? My theta is 2x. So cosine of 2 theta is 4x. Okay, well, pretty much. So now let's take a look at where we want to go. We're pretty much there, right? We can just rearrange this a little bit. Right, 1/2 times sine of 2x times 1 minus cosine of 4x. And we did it. Wasn't too bad, right? A lot of these verifying ones, don't get overwhelmed by them, right? They're really, a lot of times, just a few steps. And yeah, that was the last example I wanted to do for those. So those are our power reducing formulas. We're trading an exponent for a double angle.